Well, here we are at video number 3. We're going to be doing some more subtraction, and we're going to be doing something called borrowing. And some people believe that borrowing is one of the most challenging things in fractions. So let's see what you think. Now, we borrow all the time with whole numbers, but today we're going to learn how to borrow with fractions. So let's take a look at this problem. Here we have 2 minus 1/2. Now what this says is that I have 2 whole pies, and I'm taking away 1/2 of the pie. So here it is. I have 2 whole pies, and I'm taking away 1/2. And if I took away 1/2, I would be left with 1½ pies. True? 1, 2, 3, 1½ pies if I took away a half a pie. So 2 minus 1/2, it equals 1½. But unfortunately, I can't always make pies, so I'm going to show you how to do it with numbers. Are you ready? Here we have 2 minus 1/2, and what I do is I make an imaginary line that separates the fractions from the whole numbers. So I'm ready to subtract fractions, but there's no fraction here to subtract. I've got 0 minus 1/2. So what I'm going to do is I'm going to borrow from the 2, I'm going to make it a 1, and then I'm going to bring over 1 over here to the fraction side. Now over here we have 2 whole pies, right? It's like they're divided into 2, they're 2 whole pies, and I'm borrowing one of these pies, and I'm going to bring it over here. But I'm going to turn it into fraction form, so I'm going to put a slice in the middle, and I'm going to end up with 2 2's. Isn't that true? There are 2 pieces in the pie, and I'm getting both of them. So I've got 2 2's is what's here. Okay, now what I'm going to do is I'm going to subtract. 2 minus 1 is 1. So I'm left with 1/2 on the fraction side, and 1 minus 0 is 1, and 1 on the whole pie side. And isn't 1/2 equal to 1½? 1½ is equal to 1½ pies. So what we're doing is we've got 2 pies, and we're taking away a half of it. And in order to do that, I need to borrow one of the pies from the whole side. And I'm going to bring it over to the fraction side. I'm going to change it into fraction form. Now, if this denominator was 3, I would make this 3/3. If this was 6, I'd make it 6/6. Whatever denominator's down here is what I'm going to use for up here. But I need to borrow a pie because I have nothing to subtract in the fraction side. Let's try another one. Let's say that I have 3 pies, and I'm going to take away 2/3. So I have 3 pies, and I'm going to take away 2/3. So first thing I'm going to do is put my little imaginary line. I'm going to put my dotted line here. And here's the fraction side. Here's the whole number side. And what am I going to do? Well, nothing from 2/3. I can't do it. I need to have a fraction up here. So I'm going to borrow from the 3. I'm going to make it 2. And remember, there are 3 little pies here. So I'm going to borrow one of them. And all I'm going to do is bring it over to the other side. But when it gets to the other side, I'm going to need to cut it up into 3 pieces so that I have 3/3. 3/3. I need to have the same denominator. And then 3 minus 2 is 1/3, and that becomes 2 1/3. So 3 minus 2/3 is 2 1/3. So that's our first lesson in borrowing. But let's do a little bit more. Now take a look at the next set of numbers we have over here. We have 2 1/5, and 1/5, and we're taking away 3/10. So what do I need to do? Well, I think I'm going to make it a little bit easier for you. I think we're going to take 2 1/5, and we're going to take away 4/5. And what I'm going to do here is we're going to subtract. And again, we're going to put our little imaginary line down here. And I've got 1 minus 4 doesn't go. Right here I have the same denominators. 1 minus 4, I can't do it. So I'm going to borrow from my 2. I've got 2 pies here. And I'm going to bring one of these pies over to this side. But when I get it here, I'm going to slice it into 5 pieces. I'm going to make it 5/5. but there's 1/5 already there. So what do I need to do? I need to combine these. 1/5 plus 5/5 equals 6/5. 1/5 is already there, but it's not enough to subtract from. So I add 1/5 and 5/5, I get 6/5. Now can I subtract? Sure I can. 6 minus 4 is 2/5. 6 minus 4 is 2/5, and over here is 1 minus 0 is 1. So I'm left with 1 and 2/5. And what did I do? I borrowed from my 2, made it a 1, and I brought over here 5/5. But 1/5 was already there, so I'm going to add them together. 1/5 and 5/5 is 6/5. 6 minus 4 is 2. 1 and 2/5 is my answer. Now, my students always tell me that there's a shortcut. And this shortcut, I want to tell you, is if you don't want to bring over the 5/5 and add them together, you can simply add 5 and 1 and get 6. You can always add the numerator and the denominator together, and you will get 6/5. Or in another problem, if you add the numerator and the denominator, you will get the same as if you actually bring over the whole pie. So, let's do another one. Here we go. Are you ready? Let's take the one I had before, which was 2 and 1/5 minus, I think it was 3/10. Okay? Now, first thing I'm going to look at is, oh my, they don't have the same denominator. So what am I going to do? Well, I'm going to make them the same denominator. 5 divides into 10, so they can both become tenths. And how do I change 5 to tenths? You divide the bottom, multiply the top. 5 into 10 is 2. 2 times 1 is 2. But 2 minus 3, does it go? Absolutely not. So what am I going to do? I have to borrow. Borrow from the 2, make it a 1, and then you're bringing a whole pie over here that's 10 tenths. And if you go 10 and 2, you'll get 12. 10 and 2 is 12 tenths. 2 tenths and 10 tenths equals 12 tenths. 12 tenths. So 12 minus 3 is 9 tenths. With 1 left over, that's 1 and 9 tenths. Let's try one more. One more. Let's see how well you can do. The last one I want to show you is 3 and 1/5. 3 and 1/5 minus 1 and 5/6. Now, then my 3 doesn't come out so very good. Let's try that again. 3 and 1/5 minus 1 and 5/6, look at the denominators. Not the same. So I'm going to multiply them together, and I'm going to get new denominators. Here are my new denominators. I'm going to divide the bottom, multiply the top. 6 into 30 is 5. 5 times 5, 25. 5 into 30 is 6. 6 times 1 is 6. But 6 minus 25 doesn't go. So I'm going to borrow from the 3, make it a 2, add 30 plus 6, and I get 36. And now I can subtract. And what's my answer going to be? Why, it's going to be 1 and 11/30. So what I'd like you to do, please, is I'd like you to go to Workbook 1, and I'd like you to do the homework Part 1 and Part 2, pages 28 to 29, and pages 32 to 33. And I want you to practice. The more you practice, oh, the better you will become. And then come on back for the rest of this video, because we're going to be doing multiplication. Welcome back to video 3. This is multiplication of fractions. Take a look on the board if you would. Here we have 3 fractions, 2/4 times 4/8, and it's written 3 times, and I'm going to show you a few different ways to multiply. Now, the most common way to multiply is simply to multiply the top and multiply the bottom. It's simply to multiply the top and to multiply the bottom. Now, let's multiply the top and multiply the bottom. We go 2 times 4 is 8, and 8 times 4 is 32. So you multiply the top and you multiply the bottom. Now, looking at that fraction, do you see that it needs to be reduced? It sure does. And what's one number that you can divide into both the top and the bottom? Can you think of one? There are several. You could do 2 or 4 or 8. Let's try 8 because it's the largest number. And what we're going to do is we're going to divide by 8. And we're going to get 8 into 8 goes once, and 8 into 32 goes 4 times. So to multiply fractions, all you need to do is multiply the top and multiply the bottom. And what answer will you get when you multiply 2/4 times 4/8? Well, it's 1/4 in its lowest terms. Now, sometimes you have the opportunity to take a little shortcut. For those of you who know how to cancel, that's what I'm going to talk about next. It's called canceling. Now, canceling is really reducing diagonally. And if you don't like reducing very much, you might just want to stay to multiplying the top and multiplying the bottom. But if you like to reduce, what you're going to be doing in canceling is looking at the diagonal numbers and reducing diagonally. So when we have 2 and 8, we can reduce by 2. 2 into 2 is once. 2 into 8 is 4. And when we have 4 and 4, well, we can divide by 4. 4 into 4 is once. 4 into 4 is once. And then what do we want to do? We want to multiply the top and multiply the bottom. So 1 times 1 is 1, and 1 times 4 is 4. And isn't it the same number as this? Same answer, 1/4, 1/4. This, for some people, is considered a shortcut. If you like to reduce diagonally by canceling, go right ahead whenever you can. Sometimes you get the opportunity in multiplication problems, and sometimes you don't. Now, there's some other way that you can multiply fractions, and that's you can look at the fraction first, and sometimes the fraction might need to be reduced. And instead of waiting until the end to reduce, you can reduce in the beginning. So here I have 2/4, and I want to reduce it. And 2/4 reduced is really 1/2, right? If I divide by 2, 2 into 2 is 1, and 2 into 4 is 2. And if I reduced 4/8, it would be 1/2 also. 4 into 4 is 1, and 4 into 8 is 2. And then what do I need to do? I need to multiply the top and multiply the bottom. 1 times 1 is 1. 2 times 2 is 4. And so this is multiplication of fractions. If you have the opportunity, you might want to try to cancel, or perhaps reducing first. But basically what you need to do to multiply fractions is you need to multiply the top and multiply the bottom. Now let's do it one more time and make sure that you know what we're doing here. Let's take a look at a few other examples. Now here we have 3/6 times 9/12. And the first way, as I explained before, was to multiply the top and multiply the bottom. So 3 times 9 is 27, and 6 times 12 is 72. Now, do I leave that fraction like that? Of course not. I need to reduce, and I need to find one number that I can divide into both the top and the bottom evenly. And what is that number? Why, it's 9. So let's reduce by 9. We're going to divide by 9. 9 into 27 goes 3 times, and 9 into 72 goes 8 times. So 3/6 times 9/12 equals 3/8. And what did I do? I multiplied the top and I multiplied the bottom. Now looking at these numbers, can we cancel? Sure we can. We can reduce diagonally. 3 into 3 is once. 3 into 12 is 4 times. Let's divide by 3. 3 into 6 is 2. 3 into 9 is 3. And what do? I multiply the top and I multiply the bottom. 1 times 3 is 3. 4 times 2 is 8. So the answer is 3/8. Same answer. Let's try again. This time let's reduce first. 3/6 is really 1/2. And what about 9/12? What's that? Well, it's really 3/4. So, what am I going to do? I'm going to multiply the top and multiply the bottom. 1 times 3 is 3, and 4 times 2 is 8. So again, we get 3/8 as an answer, and this is how we multiply fractions. Now, before you do your homework, I do want to show you another problem that I think is kind of fun. And here it is. We're going to take 10 12s, and we're going to multiply it by 4/5, and then we're going to multiply that by 2 6. So there are 3 numbers here. Now, you could multiply the top and multiply the bottom, or you could reduce your 10 12ths and your 2 6, or you could cancel. Now, canceling, you can reduce this way, you can cancel this way, you can cancel this way, you can cancel this way. I'm going to start here. 5 into 5 is once, 5 into 10 goes 2 times. And then I'm going to go here. 2 into 2 is once, and 2 into 12 goes 6. And then I'm going to cancel here. 2 into 4 is 2, and 2 into 6 goes 3. And then I'm going to go here. 2 into 2 is once, and 2 into 6 goes 3 times, and I think that's all the canceling I can do. And now we multiply the top and multiply the bottom. 1 times 2 is 2 times 1, that's 2. And 3 times 1 is 3 times 3 is 9. And there's my answer. Here we go. We have 2/9 as the answer. So this is multiplication of fractions. And what I'd like you to do is I would like you to take a look in the workbook, pages 30 and 31, and pages 34 and 35 in the workbook, workbook 1, and go on and take test 1 and test 2 and see how well you do.